All right, so now that we're kind of armed with a lot of moving parts, if you would, with regards to rational functions, their asymptotes, their holes, all that stuff, what we'd like to do in Section 5.5 is put that all together and essentially generate a graph. Without a calculator, basically, is how this is going to go. You can always use the graphing calculator to check your work, but this is a step-by-step process. In a way, I kind of, this takes me to old school. I'm kind of an old guy, and this is the way we used to do things back in the past because I didn't have a graphing calculator. And so now the graphing calculator adds a little bit more spice to it. But as you go through this process, there's a lot of good math that will help you in a lot of different areas, not just to graph rational functions like we're doing in 5.5. So please make sure you're understanding the algebra and not just relying on a technology, because as we can see, as you will see, is sometimes technology, technology doesn't show you the holes. So there's one drawback right there. But at any rate, there are a lot of moving parts as we've seen, and so what we want is kind of a step-by-step process. I always found that these steps can be moved around frequently. Some people might want to do maybe one thing before another, and so you to kind of design what you want to do. The book also has kind of a seven-step process to use. So there's a lot of things you can do with regards to this. So I'm going to basically do is give you my game plan. You're going to watch me go through that game plan several times, and then hopefully you're convinced that it's good. Although if you want to mix and match some things, you can do that as well. So here's my step-by-step game plan. What I actually like to do is I like to factor the numerator and the denominator first. So basically I'm finding the zeros upstairs and downstairs. So what are my zeros upstairs? What are my zeros downstairs? As we have seen, this gives us some very valuable information. Zeros on the denominator basically tell us where I have vertical asymptotes. Zeros up in the numerator give us possible x-intercepts. And then if we have zeros in both, that tells us where our holes are at. So just taking care of business at the very beginning, finding my zeros of my polynomials upstairs, finding zeros of my polynomials downstairs, upstairs and downstairs, gives me a lot of good information. So that's what I like to do first. And then once I do that, if step 2 is if I do have a hole, then I basically reevaluate this. I take my function and I simplify it, and then I evaluate it at the value of x that I got. And so now I've located the location of my hole if necessary. My third step is to talk about the end behavior. So do I have a horizontal asymptote or do I have an oblique asymptote? And then whichever, I have to clearly define them. So am I y equals 0? Am I y equals L? Or am I some oblique where y equals mx plus b or something of that nature? So that's my third step. And then my fourth step is I at least find the y-intercept for myself, all right, at the very, very minimum. So it gives me just one other point to plot. Of course, you could also find where you're crossing the horizontal asymptote. That is a choice. I choose not to do this unless I'm needing more points. But, the book has suggested it, so I threw it in there in my step 4. But I definitely find the y-intercept. Again, it just gives me one more solution point to kind of orientate myself. And then when you put all this together, my fifth step is you put all this data together, you start sketching your asymptotes, you start plotting your points, your x-intercepts and your y-intercepts, and then using your knowledge about asymptotes and behavior, usually that's enough to get a good idea of what the overall graph looks like. It's still not going to be exact, but it's a pretty good rough estimate of what we have. And then you basically are done at that point. Don't be surprised that if needed, you might have to point plot a point or two. Throw in a value of x, see what it evaluates out to, just so you have another point to plot. So that seems to happen every once in a while as well. All right. So without further ado, let me go ahead and start doing some examples, kind of going through that step-by-step process. And so again, the first thing I want to do, right, when I'm graphing, we'll graph f of x equals 1 over x minus 2, is I'll start right away by finding the zeros. So upstairs there's no zeros, right, because we're equal to 1. So no zeros upstairs, but down below, if I set that equal to 0, we have 1. All right, and since this is the only 0 that's happening in the denominator, there's none happening up in the numerator, this basically means we have a vertical asymptote at x equals to 2. All right, so I've got that. Step 1 is done. Step 2 is already done too because there's no holes, right? I didn't have a matching 0 upstairs and downstairs, so we don't have to worry about step 3. Step 2. Step 3, what's my end behavior? Well, for this graph, the degree upstairs is less than the degree downstairs. So since the degree is 0 upstairs, this is less than the degree of 1 downstairs. This means y equals to 0 is our horizontal asymptote, otherwise known as the x-axis. All right, so there we have that. And then my fourth step is I at least find the y-intercept. So my y-intercept, we basically find what is f of 0, and so plugging that in, I get -1/2. So I have at least one point to physically plot. All right, and then what I'm going to do now is go to step 5. Let's see what I got here, and if I can't make it out, then I'll plot some more points just in case. So our vertical asymptote is at 2. So let me draw a dashed line there representing 2. And then we have a horizontal asymptote being our x-axis. So we've got that. And then I do know that my y-intercept is at 0, -1/2 right in there. So with that knowledge, I know that going in this direction, the graph is going to be hugging the x-axis. And then on this direction, it's got to be going downwards, right? Because if we'd gone upwards, right, we would have had a 0 up in the numerator, telling us where the x-intercepts are. And so since there were no zeros, that means there were no x-intercepts. I should have said that earlier. So I know this graph's not crossing the x-axis, so it has to be that. What I can also tell you is that the behavior of this function, right, at the vertical asymptote, our multiplicity is 1. And so because the multiplicity is 1, this tells me that the behavior around 2, as one side goes to -infinity, the other side has to be going to +infinity. So putting that together, then my graph has to be doing something like that. So there, putting all the stuff that we've learned so far into play is what my rough sketch of f of x equals 1 over x minus 2 looks like. Of course, you can always go to your calculator and verify that everything I have in there is pretty much true. If you want more detail, you can plot points, right? Like maybe let x equal 3 and x equal 5 or x equal 1, x equal -1, and you can plot some more details. But I think I pretty much have the general characteristics down, and so it's not really necessary. I know how I'm behaving around the vertical asymptote, the horizontal asymptote. I know where I'm crossing the y-axis. I know I'm never crossing the x-axis, and I pretty much have all my bases covered. So there you go. There's our step-by-step process. So next one, again, my first step is to basically look at where's my zeros, right? And so upstairs, x equals 1. Downstairs, x equals -2. So what that tells me is this 0 doesn't match that 0 upstairs. So we truly have a vertical asymptote at x equals -2. The 0 in the numerator tells us where our x-intercepts are. So I have an x-intercept at the point 1, 0. All right, so I have two very important pieces of data just by doing step 1. Step 2 is irrelevant because there was not a 0 in both. So we don't have to worry about that at all. What's the end behavior? Well, in this case, the end behavior, the degree is 1 in the numerator, and the degree is 1 in the denominator, so they're equal. So we have a horizontal asymptote, and we basically take the lead coefficient, which is 1, divide it by the lead coefficient, which is 1, and so my horizontal asymptote is y is equal to 1. So there's my step 3. Step 4 is to, at the very minimum, find my y-intercept. So in this case, to find the y-intercept, I will basically, so y-intercept, we look at f of 0, so that's 0 minus 1, and 0 plus 2, and we get -1/2 again. So we are crossing the crossing the y-axis at 0, -1/2. So there's a lot of data. Let's go see if that's enough. Oh, and by the way, too, the vertical asymptote, the multiplicity is 1, so we're expecting it to behave differently on either side. So putting this together, -2, I've got a vertical asymptote. All right, y equals 1, I have a horizontal asymptote. All right, we got that. And then 1, 0 is where I'm crossing the x-axis, so right there. And 0, -1/2 is where I'm crossing the y-axis. So putting this all together, this graph must be doing something like this on that side. And since we're approaching the vertical asymptote, it must be doing something over here on that side. Again, because the multiplicity is 1 for that vertical asymptote, since I'm going to negative infinity in this direction, I better be going to positive infinity in that direction. So putting this together with our horizontal asymptote, our graph must be doing that. And so again, there's a very rough sketch of what f of x equals x minus 1 over x plus 2 looks like. If I want more details, I plot more points. But right now, I think that's good enough. If you put this on a graphing calculator, you'll probably see that, yeah, that is actually true, right? We've got it going. So there's my game plan. There it is in action. Obviously, we'll do some more examples so we can practice and you guys can get used to it. Again, don't be surprised if you want to move some parts around. I do know for a fact that a lot of my colleagues do the end behavior first because that's really obvious if you just look at the degree. So sometimes they actually like to do the end behavior first and then do all that stuff. So you can mix and match it whatever you want, but there's my general flow. And you'll basically see me do that in several examples coming soon.